I skipped down to the probability problems because I'm assuming that's where the questions probably are. If I'm wrong, then let me know, and I can create videos on some other items. But this is the fourth problem. It says, according to an airline, flights on a certain route are on time 95% of the time. Well, when they give you a percent, they're giving you a little p. So 95%. Suppose 17 flights are randomly selected, and number of on-time flights is recorded. So n is 17. A, I won't go over, but B. Find and interpret the probability that exactly 15 flights are on time. So we're looking at x is equal to 15. Exactly 15. Now it's always useful to write down the x values you're referring to here. So let's come over here. This is finding our probabilities. We identify a number of trials in, which we did. We found p, which we did. List the x values of problem entails and rewrite with inequality or equality symbols. And then use a table in the following slide to determine how to enter the function. Well, this tells us that when we got the probability that x is equal to a value, we're going to use binom PDF. So this one will be binom PDF, and the order of our parameters is the NP and then the A. A is the number that's right here. So N was 17, P is 0.95, and then 15. That's our A. And we just plug that in the calculator, it'll give us our answer. Now C. Find and interpret the probability at least 15 flights are on time. At least 15. Well, let's write down what x values that means. Well, that means at least 15 includes 15. So 15, 16, and our highest is 17, our n. So that's what they're giving us. Now we're wanting to write it in one of these forms. X is equal to, x is less than or equal to, x is greater than or equal to, or x is between two values. Well, this one would be probability x is greater than or equal to 15. So to match our third form here, the A would be the 15. And we're going to have 1 minus binom CDF and NP and then A minus 1. So N, which was 17, P, which is 0.95, and then A minus 1. What was A? A was 15, so we got 15 minus 1. And that'll give us our answer. Now D. Find and interpret probability that fewer than 15. Fewer than 15. Fewer than 15. Well, that'd mean x is equal to 0, 1, 2. Fewer than 15 doesn't include 15, so it goes up through 14. Now I want to write it as one of these forms, equal to, less than equal to, greater than equal to, or between two values. Well, this is less than equal to. This is probability x is less than equal to 14. And so it's a second form here. So we do binom CDF in PA. And this will be our A. So we're going to do binom CDF in, which was 17, P, which is 0.95, and then A, which was 14. E. Find and interpret probability between 13 and 15 flights inclusive or on time. Inclusive means it includes those numbers. So we're going to have probability x is equal to 13, 14, and 15. Well, this is between two values. If I come over here, it's the last case. So this will be the probability that 13 is less than or equal to x is less than or equal to 15. Now this is going to be our A, and this will be our B. Now our formula says we're going to do binom CDF in PB. So binom CDF in, which is 17, P, which is 0.95, B, which we said is 15, minus binom CDF NP A minus 1. So I got 17, comma, 0.95, A minus 1. So 13 minus 1, or 12. And that'll give us our answer. Let's see. 15. Let's take a look at this. 15. Where'd that come from? Number 5. I'm like Mr. Magoo. Okay. According to a survey, 61% of murders committed last year were cleared by arrest or exceptional means. That's probably our P unless they change it and ask the opposite, but 61% were cleared. 50 murders committed last year randomly selected, so N is 50. Okay. A. Found probably exactly 41 of the murders were cleared. Probability exactly 41. Well, that's x equals 41. If we come over here, it matches our first form. We'll do binom PDF. And then we'll do NPA. So N was 50. P is 0.61, and A would be the 41. This is our A when it's of that form. Now B. Find a probability that between 36 and 38 of the murders inclusive were cleared. Inclusive means it includes 36 and 38. So probability X is equal to 36, 37, and 38. Well, this is between two values, the last form. So there's going to be a probability that 36 is less than or equal to X is less than or equal to 38. So this will be our A, and this will be our B. So we'll do binom CDF. I'll shorten this. I'll just do BCDF. NPB. So N is 50. P is 0.61, and B was 38. Minus binom CDF. NP A minus 1. So 50.61. A minus 1. A was 36. So we got 36 minus 1, or you could put 35 there. And that'll give us our answer. Last one. Would it be unusual if fewer than 19 of the murders were cleared? Fewer than 19. That's x equals 0, 1, up to. Fewer than 19 doesn't include 19, so it goes up through 18. And this would be x is less than or equal to 18, if I were to write down what this means, which is the second form, which is binom CDF. NPA. So we'll have 50, comma, 0.61, comma, 18. Again, the A comes from the number. The A here represents a number, and the B represents the number 2. And that'll give us our answer. Now, when they're saying unusual, see how it says is between this value and this value, or is less than this, or is less than that, type of deal. Well, remember, I try to remember the statistics. I think 95% of the data, I think it's exactly 95%, falls between plus or minus 2 standard deviations. So they're basically asking you, if 95% of the data is in between there, then 5% is in the entails. So it's asking you if your probability is less than 5%, then it's unusual. So it's kind of a weird way to write it here, but that's what they're referring to. That's a couple of examples on the binom CDF. So let me move on to the Poisson CDF and Poisson PDF. Now this one here, it's binom. There's a binomial. Okay. Now Poisson will be pretty easy to follow because I think every one of the problems actually says it follows a Poisson process. So let's take a look at this one. And let me bring up the PowerPoint that goes along with that. These are out in our math heels if you want to get a copy of it. Okay. Get there eventually. There we go. This will be number 8. The number of hits to a website follows a Poisson process. Hits occur at a rate of 0.9 per minute. 0.9 per minute. I'll learn to speak someday. Between 7 p.m. and 12 p.m. Given below are 3 scenarios for the number of hits to a website. Compute the probability of each scenario between 1016 and 1023. Well, if I were to subtract these, 1023 minus 1016, that'd give us 7 minutes. So we're looking at a 7-minute period. Okay. Now this says identify the average number of occurrences of the event in some interval, lambda. So this is per minute, so lambda would equal to 0.9. And the number of intervals t. Well, they're telling us 7 minutes, so t is equal to 7. So this says calculate your mean. Our mean is going to be equal to lambda t. So we've got 0.9 times 7. And I think that gives us, I'm not very good with decimals, but I think it's 6.3. Might want to plug that in your calculator just to make sure. Then it says, list the x values of problem entails and rewrite with inequality and use a table. So this is very similar to the one the binomial we just looked at. Okay. Exactly 6, part A. Well, exactly 6. That means x equals 6. If I come over here, these are the forms we've got. Equal to, less than or equal to, greater than or equal to, or between 2 values. So this is the first one. That tells us to use Poisson PDF. So Poisson PDF. And then our mean, which we said was 6.3, comma, A, which would be the number. So this is our A right here. So we put in 6. And that'll give us our answer. Now B says fewer than 6. Well, let's write down what that means. Fewer than 6. That'd be 0, 1, 2, 3, 4, 5. Fewer than 6 means it doesn't include 6. So if I were to write these with inequalities, this would be x is less than or equal to 5. Less than or equal to a number is their second form. So our A is going to be the 5. And that tells us we're going to use Poisson CDF. So Poisson CDF. And then our mean and then comma A. And our mean was 6.3, comma A, which would be 5. And that'll give us our answer. Now C. At least 6. Well, that means at least 6 means 6, 7, 8, and then forever. There is no ending value for the Poisson PDF. Well, this would be x is greater than or equal to 6, which is our third form. So that's going to says we're going to do 1 minus Poisson CDF. So 1 minus Poisson CDF, and then our mean, and then A minus 1. So our mean was 6.3, and this is our A right here. So 6 minus 1, or you could put 5 there, and that'll give you your answer. Okay, let's look at another one. This is number 9. Let's see. Suppose that a sample of peanut butter contains 0.4 insect fragments per gram. That's pretty gross. So 0.4 insect per gram. It's going to be our lambda. And it's per gram. Okay. Compute a probability that the number of insect fragments in that 10-gram sample. So they're wondering about 10 grams. So that's going to be our t. So t is going to equal to 10. Now notice grams, grams. So see how they tie together? So then we need to find our mean. So we're going to have lambda times t, which is 0.4 times 10, which gives us 4. and then A. The probability that there are exactly 4 insect fragments, so we're going to have x is equal to 4. That's our first form here. So we'll use Poisson PDF, and I'll abbreviate this. I'll do P PDF. Then we'll put in our mean, comma A. Mean was 4, and then A is 4. A is, again, whatever number's right here. And that'll give us our answer. Now B. Fewer than 4. Fewer than 4. That doesn't include 4. So that's 0, 1, 2, 3. If I were to write these with inequalities, this would be x is less than or equal to 3, which is our second form. So we use Poisson CDF. Poisson CDF. Mean, comma A. So mean was 4, and then A would be this number right here, the 3. Okay, C. Probably that at least 4. Okay, at least 4. That means 4, 5, 6, forever. Which, inequality-wise, would be x is greater than or equal to 4. Which would be our third form. So we'll do 1 minus Poisson CDF. Mean, which was 4, comma, A minus 1. And this is our A again, so this would be 4 minus 1. Again, that's our A. And that'll give us our answer. Last one. The probability that there's at least 1 insect fragment. At least 1. Well, that would be 1, 2, 3, forever. And so this would be probably x is greater than or equal to 1, which is the one we just did. Greater than or equal to would be our third form. So we're going to have 1 minus Poisson CDF, our mean, which is 4, and A minus 1. So this is our A, so we'll have 1 minus 1, or we could put 0 there, and that'll give us our answer. Hopefully with those two examples that using that chart makes sense. Let's talk about number 10. I'm not going to actually do it. I'm just going to do the first part of it, which is kind of the challenging part, I think. Okay. For the past 111 years, a certain state suffered 30 direct hits from major hurricanes. Assume that this was typical. Number of hits per year follows a Poisson distribution. Well, this is a little bit different to get the mean. It's kind of a challenge. It's no longer our formula that's in the book. It's not lambda times t. We got 30 hurricanes over 111 years' time. So to find the average, you take 30 divided by 111. And let me just double check those numbers. 30, 111. And then from there, you do it the same as what we just did. Again, if it asks you for if it's unusual, they're talking about the 5% mark. Anyway, people have trouble with the mean on that, but that's how you do that. I think the rest is pretty straightforward. I'm assuming that, which probably means I'm wrong. They say you shouldn't assume things, but most of this is just a you take your frequency, divide by n. N would be you add these up. And that'll give you your probability for each one of these segments. Like first one would be 2076 divided by your grand total, whatever that is. You'd add these numbers up. The mean here is pretty straightforward, I think. If I remember right, the mean is n times p, and the standard deviation is the square root of n times p times 1 minus p. Yeah, you might want to double check that and see if my memory's any good, which is not very good. Anyway, let me know if this video doesn't help, and I can create whatever area you're still having trouble with.